Hey guys, Jim Bounds at Motorhome Rehab Ranch, and this is episode 2 of Basic Electrical. I think we've really hit something here. Thanks for the comments. You brought in some great ideas I want to add to this. Now remember this though. What is our prime directive in this series? If you purchased a GMC and you've never seen any electrical system at all, and you need to drive home, that's the focus we're going to do. I'm entry level. I'm showing you enough to be dangerous, enough to know what you're looking at, and to be able to be safe to drive home. That's what the thing's about. So, the last time we met, we're talking about the battery boost solenoid, and this is where you do your test points. Right. This is the engine electrical system. Now I touched on the living area electrical system, but that's not prime directive right now. Okay. What we're interested in is getting DC 12-volt voltage from here, from this battery, along here, to this point right here. And then we need to get voltage to this point right here. Then we need to get voltage to this point, which is the horn relay. And then from here, the voltage goes to the glove box, fuse box. Okay, and that's where your ignition picks up. That's where your all your basic lights and things hook up. Okay, so this is the signal path we need to get to, and we've done that. All right. Well, we can drive, right? There's a whole lot more wires there. What are they? I'm glad you asked. Not only do we need to get voltage to here to start it, we need voltage to charge the battery to keep it running. In other words, the alternator. Now, we're only talking about the engine electrical system. We haven't even been down here to this coach battery or this coach electrical system. We haven't even come out of there yet. So we're holding on to that because what is our prime directive? Our prime directive is to get this thing started and to get it to move. All right. Now, one comment that one of you guys had yesterday, what about batteries? You're right. What about batteries? Now, remember our prime directive is to get it going. And that hole that's in there, where that battery is designed, well, I'm telling you what, there it goes. It is designed for one battery originally. Most put 2 batteries. The tray that's there, in many cases, is good for 2 batteries. Now, if you can get a Ragusa Pattern Company, RagusaPatternCompany.com, I think, or do a Google search. He makes a cast aluminum 3 battery tray that can bolt into here. It takes this entire amount. You can see my wheel liners out. I haven't had one of those in years. Ragusa's tray covers the whole area, and you can actually get 3 up there. Now, this is my coach. I have 2. I had another comment. Why don't I just take pictures of my electrical system instead of this one, and talk about it right there first person? Well, the problem is with that, my coach isn't anywhere close to original. Remember that adage, plumber's pipes always leak, kind of a thing? Well, I use my coach as a lab rat. So nearer the end of this series, I'll start bringing my coach in. But I have a very, very different system. And what we're talking about now is walking up to a coach that's been behind the barn and to get it to run. Okay, so remember that. We're not going to use my coach, okay, until later. Batteries. This compartment is designed for a battery. A regular lead acid battery is what they made in the day. Now, since then, they've got sealed lead acid batteries. They have glass mat batteries. These are all on a regular 12-volt charge and 12-volt delete system. There used to be 6-volt systems in cars. Why did they go to 12-volt? Well, because 12-volt works better than 6. You've got more pressure, right? All the 6-volt stuff couldn't be used on a 12-volt. Now, clearly going from 6 to 12-volt was a step up. And we made that transition to get rid of all of our 6-volt junk and to get 12-volt. Now we're looking at new tractor trailers are 48-volt. Why? Because you can use smaller wires to send more current and all this kind of things. How far do we want to go? We're talking about batteries here. Your alternator is designed to charge, you want to call it an analog system, an analog battery, all right? Discharge, recharge kind of a thing. If you're going to go to 48 volts or 24 volts, or you're going to be going to lithium batteries and things like this, you're going to have other supplies. You're going to have other arrangements, because this alternator, without going through converters and things, is not prepared to charge a lithium polymer battery. So you're going to have to do a lot of changes there. What kind of battery do you put in the back of the truck to go start up that motorhome? That's what we're talking about right here. This battery right here needs to be a 650 cranking amp battery, a standard car battery. Okay, why? Because it is going to the starter. Now, a standard car battery is designed for heavy current drains, short periods of time, charge up at a reasonable rate. All right, and that's what we want here, just like we want in every car. So, in essence, to start this coach is just like starting a car. And the battery needs to be the kind that just starts the car. Personally, if you're going to recover a coach, I would just go get a new lead acid battery. You know, you can get fancy at other times because you could use that battery somewhere else or put it back here or whatever. But what we want to do is recover that coach, and we know that a regular lead acid battery in this application to that alternator will work. I would get a new battery, okay? I would have it charged before you get to the coach. A lot of people say, oh, well, we'll just get it started and then let the alternator charge it up. Don't do that. That alternator is designed to put back into the battery what the starter took out, and to basically station keep the energy needs of the coach. It's really not designed to take a dead battery and to make it work. All right, so don't do that with an alternator. Start with a good battery. All right. So we've got this signal path right here. All right, this will get you down the road about 45 minutes, maybe an hour. Why? Because you're not charging the battery. I know this is going back to basics, but just bear with me. Alternator, spun by a V-belt, will put out voltage to charge your battery if it can see the battery. Now, this thing right here, originally, the alternator is connected to the center terminal on the battery isolator right here. Now, that's the reason it has these fins on it like that, is to cool it down, because it's two diodes here. And what they're designed to do is to pass current in this direction from the alternator. If you follow this one, will go right to this battery. So this alternator, through this isolator, charges the battery. Now, if you fire up the alternator, you fire up the engine, and you have a fully charged battery at 12.65 volts, if the alternator is running, your voltage will go up. Okay? Rev it one time. Sometimes the regulator that's in a one-wire alternator needs a rev one time to wake it up, to excite it. So rev it one time and watch your voltage go into the battery. If it doesn't go up, take your voltmeter, 20-volt scale, touch this to ground and touch it to right here. Right there. Right here is the exact output of the alternator. This will be the highest voltage in your coach, right there. You should see 13.4, 13.8 right there. If you don't, the alternator is not putting out. If this voltage does not go up while the engine is running, this alternator is not putting out. Is that the only reason? No. If you have voltage right here, but this doesn't go up, chances are this battery isolator, this blue fin thing right here, is bad. And if you look at this real close, this is the isolator that was in Kit's coach. His problem was the isolator was bad. It was not passing voltage right here. It was turning, it was working, but there was no voltage because the isolator was bad. This thing right here, it gets hot. That's the reason that it has those fins to cool it down. It's basically there's two big diodes poured in a material stuck into that aluminum heat sink to dissipate the heat. They do fail. All right. This isolator takes 0.8 volts. Remember we were talking in the last video about the 0.4 or 0.2 actually means something? Well, this isolator, to do its job, to allow current to flow here, but to block current from going back, takes 0.8 volts. So if your alternator puts out 13.4, okay, so it's only going to be putting out 12.65. So you're going to have to, you follow what I mean? This eats voltage. Now, in 2 or 3 videos from now, I'm going to show you how we're going to take this out of here, take it out of the circuit. But again, our prime directive right now is to get this coach moving, to get rolling. All right? So if you have voltage here, high voltage, and you have no voltage going to your battery, right here, you want to jump together. You want to take it off, take that off, and put it right to the battery. Right to the battery. Output of this alternator will charge this battery, and you'll be able to go. All right, again, our prime directive. So in this one, Kit and I bypassed this isolator. We're not using this leg here. This leg goes to the living area electrical system. We don't use the living area electrical system at all. You say, wow, that's half the motorhome. But remember this, we're trying to get this thing safe and get it home and possibly get it across country. There's nothing in the back of that, okay, that other than making it a little bit more comfortable. But remember, comfort's not what we're talking about. What we're trying to do is recover this thing. In 3 out of the 4 deliveries I've done, we bypass the living area electrical system completely. I don't worry about this battery. I don't worry about anything other than this battery supplying voltage to the fuse box and the alternator that we just covered, charging that battery. That's your minimum. You've got to have that to move and to move long distance. You've got to charge and you've got to supply power. Living area is not as important. Does that make sense? Now, if you're down the road in your home and you're worried, you're worried, you want to have your living area system work, there's a whole nother procedure for that. And what that is coming off of this side right here. This is your living area electrical system. You have to have a battery connected to it, either in the back, which would be connected to this cable that we talked about it the last time. Okay. On here will be a power converter, a charger. Back at the fuse block in the back. Let's see. Well, you know where the fuse box is back there in the back. This is an old power converter. I do not want to use that power converter at all. That's called a buzz box. Let me see if I've got a better picture of a buzz box here for you. Yeah, here we go. This is a buzz box. Originally, that was your charger. Now, this buzz box was plugged into this outlet right there. Now, above the outlet, there's a switch. It says water heater. Does that control this plug? No, it does not. This water heater switch only controls the water heater. You can turn it off. When you're going down the road, you want to have that in off position. Always. The only time you want to have it in the on position is when you want to use it. It has a heat exchange, electric heat exchange. So while you're driving, it's free hot water. You only want to turn this on because that's about an 1100 watt drain on your system. Okay, so if you're plugged into, say, a power cord or something like that, you want that off. But this switch does not control this outlet right here at all. This outlet is here for the power converter. You can overcharge your batteries, boil out all the acid, and burn up your batteries with this charger. Because back in the day, that they did not turn off. In essence, this is a 50 amp DC welder. It's heavy, huge transformer in there. And if you do not unplug this, if you're plugged into your outlet outside your house or whatever, this thing is on. It's plugged in right there. You can see here, here's the cord. It is unplugged. Why? Because I do not want this connected to anything. That should be taken out. And if you still have this and it's plugged in right there, go over there and just politely unplug it. And we'll talk about that now, but do that immediately. You do not want to use this power converter. What we used at the co-op was a PD Dynamics brand Intellitech 40 watt or above. Okay, 40 amp or above, 40 amp charger, 45 amps, something like that. Take that out, you put the other one in here. It's connected right there to the fuse box, right there. All right. If you have a generator running in your coach, if you do, you can run your power converter. And if your alternator is bad, you can drive with your generator running the power converter charging the battery with a jumper right here. Remember, this side is your living area electrical system, and this side will be hooked up to your battery into this converter. If the generator's running, the generator will run this power converter, which will put voltage here. So you'll have positive voltage coming here. Over here, the alternator does not. Say it's bad. Well, run your generator. You got voltage here. If you take an alligator clip and jump across here, from this leg to that leg, right there, fire up your generator. Power converter runs the generator, generator runs the power converter. Power converter puts voltage here. You jump it over here, you'll be able to drive. Make sense? it would be much preferred if the alternator runs. But I have recovered coaches with the generator would run, the alternator would not, and you use voltage here to run voltage here. What does this do? Well, when it's the right thing, there's a button on your dash that says battery boost, right? You've seen that button. When you push that button, you'll hear this thing click, click. And what it does is ties them together, not having a clipper. It actually ties them together. Now understand this. This thing pulls about 4.5 amps. So the entire time that thing's together, if you're not plugged in, this is a draw when that button's in. So you don't want to really do that. That's for a momentary use. You're sitting there and the engine won't quite start. You push that boost, the rear battery will boost your front battery and give you that extra energy to start. That's what this thing is for. That's why it's called a battery boost solenoid. So to get your voltage, you can get it from the generator through this. You can get it from the alternator through this. If this is bad, you bypass that. Your prime directive is to get power to here, and sustainable power. That's the big deal, sustainable power. All right. Well, look, we're at another 20 minutes. I want to make these things not too long. Don't make them a Bible or anything like that. But I want to cover all the things you need to know when you go walk to a coach. Today, we've covered charging. Great. Thanks for your time. I hope this is helpful. We'll see you next time. We'll see you tomorrow.